Right, for those of you listening at home, hi Rainey, we're praying for you. We're going through 14E-1, tide problems. I'm just going to work my way through this. It's probably faster than reading off the answers and then working it anyway. Let me see. 212. Okay. I'm just going to carry this. I don't give myself a big water. Number one. The graph should look like this. The high tide and the low tide should be marked right away. The high tide has to be 6.48 feet. The low tide is 3.22 feet. Question, how do you find the baseline? Yeah. Right, find the average. What do you get? 4.85, correct. Basically, it's 6.48 plus 3.22. Divide by 2. Everybody good with that? How do you find the amplitude? Well, yeah, 6.48 minus 4.85. Which I forgot already. So what do you get? What do you actually get as an answer? Not quite. That was the previous.
I wrote it wrong. Shoot.
Okay. Megan, what do you get? 1.63. Correct. Does that make sense? And it should be the same on the top as it is on the bottom. Just do a subtraction there, it should be good. All right so far? Now, we've got the amplitude, we've got the baseline. We need the horizontal shift and we need the period in order to finish this. So, the first high tide, 4:45 a.m. And this starting point is supposed to be July 1st, 2022. At midnight. Or midnight. Okay. That is a high tide. So it should be a dot at the maximum. Then the first low tide is at 1:30 p.m. on the same day. So, what can you figure based on that? And what would we have to do in order to further this problem along? I'll give you a hint. This is kind of, a calculator is like a miniature computer. They do not understand human time. You have to convert it to something. Same. Like 4:45 a.m.
That means 4.75.
Right. How do you get that?
You do 45 divided by 60.
Right. It's 4 hours plus 45/60ths of an hour. Every minute is 1/60th of an hour. So if you have 45 minutes, it's like 3/4 of an hour. You can reduce that to 4.75. If you get a decimal that's horrible, you can do one of two things. You can leave it as a fraction, which gives you a better answer. Or in this particular case, if you must round a decimal, please round it to at least 4 decimal places. If you have more than that, that's great, but at least 4. This one you don't need to round. 1:30 p.m. Josh, what's that? Yeah, how do you get that? Yeah, where'd the 12 come from? From what? Yeah, so in other words, covering the morning. If you're in the afternoon, you've got 12 hours in the morning, plus 1, plus what? Yeah, 30 over 60, which is 0.5. So you're right, this is 13.5. Those will serve two purposes. Number one, you've got a starting point. Can somebody tell me where should I draw? Like obviously the graph goes through that point. When it goes zing, 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 zing multiple times, kidding. Why not? Right, this has to be the first low tide afterwards, so it has to go smoothly down. If you want, and by the way, I don't say you have to do this, but if for whatever reason you want to find that point in the middle, you can. Can you remember how? Where is it? Where do you look for it? Like physically speaking, where do you look? Let's. It's exactly halfway, correct. This thing, the nice thing about sine and cosine is that it never speeds up and never slows down. It's just sort of steady, steady, steady. So anytime you want a point in the middle, you could if you want. You don't have to in this problem. But that brings me to another question. Becca, what kind of a start point is this graphing-wise? It is positive cosine. We're not going to use it, but what would this be if you wanted to use it? A negative sign. If somebody insisted on a negative sign equation, you could find it. It's extra work. You basically take the average of these two, so go exactly halfway between. I know, not gonna bother. Mary Claire, what kind of starting point is this? Negative cosine, correct? Okay. Is everybody good so far? So we've got some stuff up here already. Spencer, how much of a period is this? Half a period. So theoretically, it's going to keep going up and hit the whole period. How long is the half period? How do you find it, first of all?
18.
Say again, sir?
18.
Other way. I want to know how far it is from 4.75 to 13.5.
Would you do 13.5 minus?
Yes, so just plain old subtract. What do you get that then? 8.75. So a half period is 8.75. What's the whole period? How do you do that?
You would add 8.75 to that or double it.
Yeah, add another 8.75 or multiply by 2, whatever your favorite is. What do you get? 17.5. That will be useful. We need that for a formula. Any questions so far? Yes. So we've got the amplitude, we've got the baseline, we've got the period, and we have two horizontal shifts, depending on which one you want to use. It's actually up to you. They didn't say, they didn't specify use one over the other. You notice on it says number 2, identify at least 2 start points. I would strongly recommend you use this one and this one. They're by far the easiest. If you want to be creative, if you just have creative juices and you just feel like in 15 minutes of your life you have nothing better to do than find a positive sign start, you can do that. Go halfway in between these 2 points. And if you can find the quarter period, you can add a quarter period, and that works too. Add a quarter period, add a quarter period, add a quarter period. You can find any starting point you want. But let's go to the main point. Abby, you're on. What is the formula for, I would like to do positive cosine from beginning to end.
So,
What does it always start with?
y,
Y equals good.
6.48.
You're on the right track. By the way, what letters do we use?
Oh, A,
A.
cosine,
Cosine, yeah.
parentheses,
Close.
minus.
A cosine parentheses what?
Does it have the B?
It's a B, yeah, okay, I thought you said C. And that parentheses, good.
X minus H.
Good.
Plus K.
Paren plus K. So what's A?
6.48.
That's the maximum. A sort of stands for what? It's actually the word starts at amplitude. How much is it? how much it wobbles from the baseline. Exactly, good. In this particular case, would you do positive 1.63 or negative 1.63?
Positive.
Yeah, tell me why.
Because it's positive.
Right. Positive cosine graph, use a positive 1.63. Keep going.
And then 2 pi,
Cosine. And then what?
2 pi over 17.5.
Excellent. V is equal to 2 pi over P. So 2 pi for what? I'm sorry.
17.5.
Good. And then paren, take over, or
X, minus 4.75.
good. Don't put 4.45 by mistake. I've seen people do that on the test. Do it in the computer language. 4.75 and then what? Plus what? What does K stand for? There's only one thing we haven't used on the graph yet. The baseline. Where is that? Yeah, 4.85 exactly. Does that make sense? This is the equation you're going to be using. If you do not have a calculator with you, grab one now. You'll need it, and you'll also need it for the worksheet today. And don't forget to put it back right back. So we've got part 1, part 2, and part 3 done. Part 1 is the graph. Part 2 is the start points. I should say for the start point, the positive cosine start point is 4.75, comma 6.48. And the negative cosine start point is 13.5, comma 3.22. Those are the answers here and here. Those are the answers for number 2. There are others. You can do positive sign, negative sign if you want. Those are a little harder to find. They would be something, comma 4.85. Number 3, find a valid equation. Got one. You're welcome to do negative cosine as well. Just use 13.5 as your horizontal shift. If you really want to be exotic, you can do positive sign or negative sign. Make sure you have the correct horizontal shift. Number 4. What is the height to 4 decimal places at 7 p.m. July 1st? You know it's the same day. 7 p.m. Can somebody tell me on the same day? Can somebody tell me what X is? Yeah. Go, second. Yeah, how do you get that? Yeah, it's p.m., so it's plus 12. And then 7 extra hours. So it's 12 plus 7, better known as 19. What do I need to do with that? Exactly. Plug it in place of X into the cosine equation. Now, get your fingers busy. This should be in, by the way, radian mode. If your calculator is not in radian mode, switch it to radian mode. If you don't know how to do a radian mode, check with me. So I've got, just type this in. Don't type the y equals. Just on the main screen, type 1.63 cosine, parentheses, 2 pi divided by 17.5, new parentheses, but instead of x, put 19. 19 minus 4.75. Close paren, plus 4.85, and I'm curious what you got. Anybody want to courageously share their answer? Go. Good. You got it. 5.4906. 5.4906 what? Yeah, feet. Correct. We're measuring the height of the tide. Ta-da. Got it. Good right with that. Keep that on the screen, by the way. I will show you, if you have a TI calculator, I'll show you a shortcut to get this. If you don't have a TI calculator, maybe you can figure it out on your own. If your calculator has a memory of what you typed before, you can do this. We want the height of the tide at 8:24 p.m. on July 3rd for problem number 5. 8:24 p.m. July 3rd. You notice we're no longer on the starting day. Now, there are lots of ways you can conceptualize this. here's what I use. You can use it or use something else as you like. I like to draw a little miniature timeline. So where X is 0. This is midnight, July 1st. Does it make sense that all of July 1st is going to go from what hour to what hour? From 0 to what? If you go through an entire day. What do you think? Make it 24. Actually goes 24 at the end of July 1st, beginning of July 2nd. And if we're in the middle of July 3rd, does it make sense we have to go through all of July 1st and all of July 2nd? So you're going to go past 48. This is July 2nd. We're going to go past that. We're going to be into July 3rd. Now July 3rd goes to 72. We're not going to go all that way. We're going to go most of the way. 8:24 p.m. is close to the end. Where? Tell me how many hours have gone by since the beginning of the experiment. Austin, help me out. Now, first of all, how many hours in the whole day so far?
24.
Yeah.
Oh,
48 plus what? See where the 48 come from, everybody? The 2 extra days we went by already? Okay, go ahead.
And then, it would be 20, yeah, like 20 hours for the 8. Yeah.
How'd you get that? How'd you get 20?
Because you would add 12 since it's 12 hours that's already passed. Since it's
12 for the PM, okay.
And then
Plus?
Plus the plus
8 whole hours, plus
8.
what?
And then 24 over 60.
The minutes is 24 over 60. I want to get the total number of hours. So 2 days is 48 hours. The morning is 12 hours. The stuff you used in the evening is 8 hours. And then 24 minutes, 24 out of 60. Total it up for me.
So that would then be 70.
What's this so far?
68.
68. And then, what on earth?
And then, so you divide by 6.
6. So what is it?
4 over 10.
4 over 10. What decimal is that?
0.4.
0.4. That is your target value. I would like you to type that in place of X. That is going to be in place of X for number 5. Again, you could just retype the formula if you want. If your calculator is annoying, I would suggest you do that. But if your calculator has what I call a double display, where 1 line for typing and 1 line for the answer, they usually allow you to scroll up using the arrow keys and retype on the original formula. So let me see what we got. 68.4. Who's got it? Who's feeling brave or reckless? Yeah. Hang on just a second. 1.63. I want to make sure I didn't do a typo. How does that do that math? 2, 4. I got something different. I'm printing. But by the way, I'm glad if you got a everybody see you should get a number between 3.22 and 6.48. So if you get a tide of like 7.5, you know something horrible has just happened. That means there's some sort of parentheses that's wrong. Anybody else got a number? Good. You got it. This, the tide height, is approximately 3.7886 feet. The biggest cause of pointer loss on this is if you miss a minus sign or lose a parentheses. The parentheses do matter. If you don't have parentheses in front of the x, in this case in front of the 68.4, you will get the wrong answer because it'll multiply instead of add. Or add instead of multiply. Clear? All right. I have another dose of the same thing, but with a curveball thrown in. This is homework number 14F-1. I need to talk you through problem number 5. Problem number 5 is a little different. Problem number 5 on the previous thing we just did was just another version of plug in another value of x. And I think I told you on exams and on Jeff's test on this, for extra credit, I'm very fond of saying, okay, tell me the tide October 3rd, 2048. So go like 24 years into the future. And then you have to count leap years and what have you. Did I give you one? Okay. Did I miss anything? Good. So look on the back page. A little different. Find at least one time during April 10th when the height of the tide was exactly 2 feet. Please write in the instructions. I want you to add a couple words. To the nearest minute. To the nearest minute. You don't have to go to the nearest second or something like that. To the nearest minute. When was the height exactly 2 feet? You'll notice this one has different tides. It goes from 1.66 to 7.20. So there are multiple times when it's going to reach a height of 2. Yeah. Yeah. Leave the door track and come back in. Clear? So far? Again, you're starting your measurements on a different day, April 8th, 2023. So where the future is. And go from there. Number 1 and number 2 are almost exactly what we did here. Number 3, almost exactly what we did here. Number 4, again, they'll just say April 13th. That is kind of in the future. It's like 5 days in the future. So you're going to have to do some addition to get the total amount of hours. But number 5, my recommendation is look at the graph, because April 10th is the 3rd day in. I would do a sketch like this. And then I would actually sketch the graph. And then it's a matter of guess and check, which I almost hate to say. Let's just say, like here, somebody asked me, when is the graph equal to 4 feet? What I would do is I would put a line in 4 and eyeball it. You notice on the first day there are 2 times it's 4 feet. Here and here. If I want to know what time of day it's 4 feet, I'm going to aim either here or here. And you can kind of guesstimate. Like this is 4:45 a.m. I didn't draw this very proportionally. But it's somewhere between 4:45 a.m. and 1:30 p.m. I would guess like noon or 11 a.m. or something like that. In other words, take that value, plug it in, and see what happens. See how close you get to 4. If it's too high, go further in the future. If 11 o'clock is too high of a tide, try 11:30. Try 11:35. Try 11:36. The closer you get to 4, or in this case 2, the better. Eventually you'll get so close that moving forward 1 minute or moving backward 1 minute makes it worse. That's your answer. Okay. The rest of the hour is yours. You may work in groups. You may work alone on this if you wish. I encourage you, especially in number 5, work together. Brainstorm together. Because if you have a lot of people trying a lot of different values of x, it goes a lot faster. So go to it, and Randy, I'll email a copy of this to you. God bless your efforts, and click like and subscribe. See ya.